Okay. The first two questions are asking us to multiply, simplify completely, and showing all our work. So number one, you've got a binomial times a binomial. We'll use the FOIL method. So first times first is going to give us 20x squared. And then the outside is going to give us a 50x. And then the inside is going to give us a 6x. And then the last times last is going to give us 15. Combine like terms. So these are both x terms. We can combine them to make a 56x. Drop down that plus 15. Drop down that 20x squared. And we have simplified completely and shown our work. Okay, number two, we've got a binomial. That quantity is being squared. So this is the same thing as 3x minus 11 times 3x minus 11. Using the FOIL method, we have our first times our first is going to give us 9x squared. Our outside is going to give us a negative 33x. Our inside is going to give us also a negative 33x. And our last times last is going to give us a positive 121. Combine like terms. This is going to give us a negative 66x. Drop down that 121. Drop down that 9x squared. And we have now multiplied and simplified completely. Remember, this is going to be a perfect square trinomial. And that equation or formula tells you that if you have an a minus b squared, which is what we have right here, the product is going to become a squared minus 2ab plus b squared. So 11 squared is 121. A times b is going to give us, double AB is going to give us a negative 66x. And then a squared is our 9x squared. So you really could have just used this formula to get to the product. Moving on to numbers 3 through 14, where it is asking us to factor completely. All right, when we're given a trinomial, we're going to use the reverse FOIL method, and I am using pencil in case for some reason my first try does not work. Let me actually do this in the middle, giving me a little bit more space. Okay. So this is our first times our first. Let's try 3x and 7x. So 21 is either 1 times 21 or 3 times 7. That's it. And then 4 is either 1 times 4 or 2 times 2. So let's try 2 and 2. If they multiply to give you a negative, they are going to be different signs. And I always like to do that last. So let's find our outers and our inners and see what they combine to be. So our outer combines to be a 6x, and our inner combines to be a 14x. And these do not give us 25, so we're going to have to try something else. That's okay. Let's try 1 and 21. And I guess this does make a little bit more sense since our combined term is a larger number. And so if we're going to do our outer times our inner, and we want it to be a negative 25, what if we do 4 and 1? All right. So this is going to be a 4x, and this is going to be a 21x. And to get a negative 25, we would need a negative 21x and a negative 4x, which does not combine to be a positive 4. So it looks like this one may not be factorable. Let's just try one more. Let's go back to the 3x and 7x, and let's try the 1 and the 4. Put the 4 here so we could get a bigger number. So this is a 28x, and this is a 3x. Ooh, we can get a negative 25 out of that. If this is a negative 28, that means this has to be a negative 4. Negative 28 plus 3 is negative 25, so this has to be the positive. And we have factored completely. Remember, you can multiply it out using FOIL, finding the product, and double checking to make sure that is the correct answer. All right, moving on to number 4. Right away, I see that there is a common factor in all 3 of them. Not only do each of them have an x in common, but they also have a factor of 3. So let's see what we get. If I take out a 3x from each one, I'm going to be left with x squared plus 12 divided by 3 is 4. X, subtract your exponents, and then minus 63 divided by 3 is 21, and your x's divide out to be a 1. It's a 1. Okay. All right, so now we're going to use the reverse FOIL method. This right here is our first times our first, and this is supposed to be our last times our last. Again, 21 is 1 and 21, 3 and 7. We want to get a 4 when they combine, so we're going to use 3 and 7. Our inner is 3x. Our outer is 7x. And if we want to get a positive 4, that 7 is going to be positive and the 3 is going to be negative. And we still have that 3x out in front. This would be our final answer. Moving on to number 5. No common factor, so I'm going to go straight into reverse FOIL. So 4 can either be 1 times 4 or 2 times 2. Let's do 2. And then 3 is prime, so we only have one choice. Let's see. Our outer is going to give us a 6x, we're multiplying, and our inner is a 2x. Right away, we can get negative 4 when the 6 is negative and the 2x is positive. See if that makes sense. So if our product is a negative 3, that does work. So this would be our final answer. Number 6. 12, 8, and 20 are all divisible by 2 and 4. And that'll be the greatest one, so 4. Let's see what we get when we factor out that 4. 12 divided by 4 is 3. 8 divided by 4 is 2. And 20 divided by 4 is 5. All right, let's do our reverse FOIL. 3x squared is prime, just 3x times x. 5 is also prime, so we only have 1 and 5. So our outer and our inner needs to combine to be a negative 2. So let's put our 5 here and our 1 here. 3x times 1 is a 3x. 5 times x is a 5x. We want it to be a negative 2, so that's going to be a negative 5 and a positive 3x. This would be our final answer. Number 7, got some big numbers. Nothing, so we can divide by 2, 2, not 2. 5, 5, not 5. So I also noticed that I can take the square root of 25x squared. I can also take the square root of a positive 16. And so the square root of 5x squared is 5x, and the square root of 16 is 4. 5 times 4 is 20, so this is a perfect square trinomial. So the perfect square trinomial tells us that if we have something in the form of a plus b squared, its product is going to look like this. So if you notice, b squared is what's giving us 16, and a squared is what is giving us 25x squared. So that means that two AB is going to be 2 times A times B. Let's see if it works. So if A squared is 25x squared, A is the square root of that. So that's a 5x. And then times B, if B squared is 16, the square root of 16 is 4. 5 times 4 is 20, times 2 is 40. So it does check out. So this is going to factor into our A plus our B squared. So an easy way to get here is, again, make sure this is a perfect square, which it is. Square root of 25 is 5. Square root of x squared is x. And then here, the square root of 16 is 4. If you multiply these two, you get 20. And then double that, you get a positive 40. So that's an easy way of checking and making sure. Make sure this is on this right here. Here we go, looks much better. Okay, number 8. X squared minus 21x plus 68. It's a pretty simple one, although 68 has quite a few factors. So we have 1 times 68, 2 times 34, 3, 8 plus 6 is 14, so no. 4 times 28, 17. Have we got to 21 yet? 14, or 17 and 4. Okay. 17 and 4. So our outer and our inner is supposed to give us a negative 21. This is a 4x. This is a 14x. Oops, I meant 17 right here. There we go. To get a negative 21, they both have to be negative. Make sure, so when we multiply, negative 17 has a negative 4, it does give us a positive. So here is our fully factored form. All right, number 9. Number 9 is a difference of squares. I know that because there's only 2 terms. That's one of the things that gives it away. And there's a minus sign. So difference of squares tells us that if we have something in the form of a squared minus b squared, it can be factored into a plus b times a minus b. Which really all you have to do is just find the square root of a squared. That'll give you your a. Take the square root of your b squared, and that'll give you your b. So let's do that here. The square root of 36 is 6, and the square root of x squared is x. The square root of 100 is 10. It looks like in the beginning, maybe we could have taken out a greatest common factor. So let's look again. Now the reason how I found that is before I erased, what was this, an x plus? Okay. If you remember what we were getting, it was 6x and a 10, which both are divisible by 2, which means I should have factored out a greatest common factor. So 36, we have 1 and 36, 2 and 18, they're both divisible by 2, 3 and 12, 4 and 9. They are both divisible by 4. And then 6 and 6, so it's going to be 4. Taking out a 4, we're left with a 9x squared minus 25. Still a difference of squares. Remember, a squared minus b squared is equal to a plus b, a minus b. Okay. And we know we can do this if there's two terms in a minus and both terms in there are perfect squares, which they are. The square root of 9x squared is 3x. The square root of 25 is 5. Plus, minus. Okay. Number 10, also a difference of squares, so we can use this. I know it's a difference of squares because x to the 8th is a perfect square. Remember, a perfect square means that you can split it up into a product of something times itself. So like x to the 8th is really x to the 4th times x to the 4th. Therefore, it is a perfect square. In other words, when you have an exponent like this, just divide it by 2, and you have now taken the square root of that term with the exponent. So just take that exponent and divide it by 2. Okay, so using this right here, we have the square root of x to the 8th is x to the 4th. The square root of 1 is 1. Normally we would be done, but as you can see, this right here is a difference of squares. So this can actually be broken down like this. The square root of x to the 4th is x squared. The square root of 1 is 1. We still have this x to the 4th plus 1 out in front. And what do you know? We have another difference of squares. All right, let's put this here. Now this right here can factor into the square root of x squared is x. And again, the square root of 1 is 1. Phew. Completely factored. This was a nested polynomial. So not only did you get to factor once or twice, you got to factor 3 different times to get to your final answer. All right, looking at these two terms, maybe it's a difference of squares. It is a minus, so let's just see. There is common factors. So we can take out an x squared out of both of them. We can also take out a factor of 2. So let's say what we get when we do that. 2 divided by 2 is 1. X squared divided by x squared is also 1. 1 times 1 is 1. So you don't have to write both of them. Minus 162 divided by 2. If you don't know what that is, you can use this calculator. So that's 81. And then x to the 6th divided by x squared, subtract your exponents, you get x to the 4th. This is a difference of squares, and I know that because there's a minus, and both of these are perfect squares. The square root of 1 is 1. The square root of 81x to the 4th is 9x squared plus minus. And this is another difference of squares. So I'm going to move it up this way. Equals. This 1 plus 9x squared cannot be factored again, but this one can. The square root of 1 is 1. The square root of 9x squared is 9x. Plus, oh, that's going to drive me nuts. Let me make this look a little bit better. Okay. All right. 1 plus 3x, 1 minus 3x. And you can switch the order, meaning like if you wanted to put the 1 minus 3x first and then the 1 plus 3x next, you could do that. You cannot switch this order. So if you put 3x minus 1, that would not be a correct answer. Okay, moving on to number 12. Again, a difference of squares. I know that because that's a perfect square. This is a perfect square because remember, this is really x plus 3 times x plus 3. All right. Square root of 16 is 4. The square root of x plus 3 squared, remember, take this and divide it by 2. So we really just get that quantity, x plus 3, plus and minus. Simplify each of these parentheses. So this really has that invisible 1 out in front. We know that distributing a positive 1 doesn't change anything. So this is just 4 plus x plus 3. Here we're distributing a negative 1, so that is just going to change the signs. So this becomes 4 minus x minus 3. We can combine like terms. 4 and 3 together make a 7 plus x. And then 4 and a negative 3 is a 1 minus x. Completely factored. Okay, moving on to the next one. Again, this is also a difference of squares, right? Perfect squares, difference. So we're just going to use the rule or the formula. Make sure I can fit everything in there. So the square root of x minus y quantity squared is going to be that quantity, x minus y. And then the square root of 4a plus b quantity squared is the quantity 4a plus b. Quantity 4a plus b. Plus and minus. We need another close right here. There we go. All right. We know when we distribute a positive 1, nothing changes, so this has a positive 1 as well. This becomes x minus y plus 4a plus b. And then the next one, again, positive 1, doesn't change anything. So this is just an x minus y. But this negative 1, we'll just change the sign. So minus 4a minus b. You might see an answer choice. I don't know if this is going to be a multiple choice question or not, but because there was no combining like terms necessary, you might see an answer where the quantities stay within themselves, like this. So what we started out with. Let's say this one, but these are the same. All right, number 14. Number 14, you need to see this as 3 different terms. So this is our first term right here. And this is our second term. Negative is along with it. Okay. And then this is our third term right here. Negative along with it. It is a trinomial, which means we can factor using that reverse FOIL method. The only difference between this one and let's say this one is that the variable used is x, where here the variable used is n plus m. No different, just a little bit messier. All right. Well, if this is my first times my first, my only option is going to be n plus m, so that quantity times itself. N plus m times n plus m is that n plus m squared. All right, so we are trying to get to a negative 63 and combine to be a negative 2. That's going to be a 9 times 7. So the outer right here is going to multiply to be a 7n plus m And then this right here is 9n plus m, 9 times n plus m. And if we're trying to get a negative 2, that 9 is negative and the 7 is positive. Again, there is no combining like terms happening. So this can be your answer right here, or the one without the parentheses at all, because there's a positive 1 in front. Distributing that 1 doesn't change anything on both of them. So it can also be written like this. Okay. Moving on to numbers 15 through 18, it says solve each quadratic equation by factoring. Solve by factoring, show all your work. Oh, you know what? I meant to show you a way of double checking your answers. So if you look at numbers 1 all the way through number 14, if you ever want to double check, you can go to your Desmos, and this really works for any question that you see, whether it's in this unit, the next unit, if you're simplifying, or if you're just simplifying in general. That means that your first equation, let's do this one, your first equation is the same as your second, not equation, expression, sorry. Your first expression here is the same as your ending expression because you're just simplifying. They are the same, just written in a different way. All right, so let's type in number 6. So 12x squared minus 8x minus 20. And you'll get a picture of a quadratic. And let's type in our answer, or sorry, our simplified expression. So 4 parentheses, 3x minus 5, close those parentheses, and then x plus 1. And you'll notice that they are both lying right on top of one another, and that is because this is the same exact quadratic as this one. They're just written differently. That's how you know you got it right. So that works for factoring. That also works for simplifying. All right, number 15. Here we go. Solve by factoring. So let's factor number 15 using the reverse FOIL. But wait. The first thing we need to do is check for a GCF. All of these are divisible by 2. When we take out that factor of 2, we get x squared plus 4x plus 3. It is still equal to 0. Now we're going to factor the quadratic into 2 linear factors. So factors of 3 are 1 and 3. And if they're both positive, your outers and your inners, 3x and 1x, combine to be a 4x. Still equal to 0. The whole reason we do this is because we can use the zero property. And what that tells us is that if our product is 0, one of these must be 0. So what we're going to do is set each of these equal to 0. Set x plus 1 equal to 0. Set the x plus 3 equal to 0. When you have just a factor out in front without a variable, you do not need to set that one equal to 0. So x equals negative 1, x equals negative 3. Write your answer from least to greatest with braces. All right, number 16, let's move this guy over. So we get x squared minus 144 is equal to 0. So to be able to solve by factoring, it does need to be equal to 0. So if something moves over, it just changes its sign. Difference of squares. Square root of x squared is x. Square root of 144 is 12. Plus minus. Set each linear factor equal to 0. We're going to get x is equal to negative 12, and then x is equal to positive 12. Write your answer from least to greatest. Okay, number 17. It's already equal to 0, two terms, not a difference of squares because 21 is not a perfect square, but we can take an x out of both. So this becomes x parentheses, x squared divided by x to the first, subtract your exponents. X divided by x is 1, so you're left with 21 times 1, which is 21. Remember, they don't just poof go nowhere. They're dividing out to be 1. We do have two linear factors, set each of them equal to 0. So x is equal to 0, x minus 21 is equal to 0. This one's solved for. Here you're going to get x is equal to 21. Write your answers from least to greatest with braces. Last one, 3 terms. Reverse FOIL, it's already equal to 0. Our last times our last is prime, so we're going to start with that. All right, we want it to be 5, so we have 1 and 12, 1 and 12, and 2 and 6, 2 and 3 is 6, and 6, what if this is 6? How about 3 and 4? Yes, so 3 and 4. So what I just did in my head, I was going through all my factors of 12 and seeing which one would work to get me 5. So 3 times 3 is 9, so this becomes 9x, and this is 4x. But we want to get a positive 5, so this 4 is negative. Remember, this negative 4x is our product of these two, so that's a minus 1. This is a plus 3. Make sure negative 1 times positive 3 is negative 3. All right, set each linear factor equal to 0. Add that 1 to both sides. You get 3x is equal to 1. Divide by 3, x is equal to 1/3. Subtract 3 from both sides. Divide by 4. Write your answer from least to greatest. Using braces. Okay. And you can double check your work as well using Desmos. Remember, Desmos is our friend that we can use to check our answers. Where did my Desmos go? Here it is. Okay, so what you're going to do is type in your original. I'll do the first one. So 2x squared plus 8x plus 6. And we're trying to find out when it's equal to 0. When does the equation equal to 0? That's kind of like saying when does y equal to 0? Let's see. So our solutions are when x is negative 3 and when x is negative 1, which is what we got. So you can always check your answer using Desmos. Make sure you're looking at this side as well. Remember, if we're solving by factoring and using that 0 product property, it needs to be equal to 0. So which means you are comparing it to that line y equals 0. All right, numbers 19 through 21. Simplify each square root. So there are multiple ways to do this. The least amount of work is to figure out how to split 45 up into a perfect square times another number. For instance, if you don't remember your perfect squares, let's see, x squared. Here are your perfect squares. So like 1 all the way down. 1 squared is 1, 2 squared is 4. And if you notice, so 9 goes into 45. So this is really the square root of 9 times 5, right? It's still saying the same thing. 9 times 5 is 45. All right, so this is really, you can split up that radical. So 3 times the square root of 9 times the square root of 5. Keep simplifying. 3 times the square root of 9 is 3 times the square root of 5. Simplify. 3 times 3 is 9, square root of 5. Can you go from here to here? Of course. All right, 50. I know I can multiply 25 times something. And 25 is one of my perfect squares. So 25 times 2. So that's the square root of 25 times the square root of 2. The square root of 25 is 5. So 5 square root of 2. All right, and then number 10, let's see, 10 square root, 18 is divisible by 9. Let's do 9 times 2. So 10 times the square root of 9 times the square root of 2. So this is really 10 times 3. Square root of 9 is 3 times the square root of 2, which is 30 square root of 2. And once again, you can use Desmos to check your answer. Type in your original, 10 square root of 18. You're going to get a decimal. Type in your simplified answer. Again, when you see the word simplify, you can always use Desmos to check your answer. The original and the simplified version are saying the same thing in a different form. 30 square root of 2 is what we got. Notice our decimals are the same. All right. Numbers 22, 23, and 24. Okay, solve using the square root method. What you cannot forget about using the square root method is that, let's say we have, I don't know, x squared is equal to 16. And if you wanted to solve for x, you could take the square root of both sides, and you would get x is equal to 4. But remember, 4 squared gives you 16. Negative 4 times negative 4. So negative 4 squared also gives you 16. Both of these are your answer. So when you are doing this, and you're solving using the square root method, you're going to take the square root of both sides, but you have to put a positive and negative of that square root. So let's use that method here. You do need to make sure that your squared value, your squared term, is isolated, which this one is, because it's a quantity being squared. So once we square root both sides, that's how we get rid of this square. So what we're left with is x minus 2 is equal to plus or minus the square root of 50. Solve for x by adding 2 to both sides. X is equal to, normally you put the 2 out in front. And let's see if 50 can be split up, the square root of 50. 50 is divisible by a perfect square, 25. So that's going to be the square root of 25 times 2, which is going to give you 5 root 2. So instead of it saying 2 plus root 50, it's going to say 2 plus or minus 5 root 2. All right, let's look at this one. So what we're going to have to do is get this quantity squared isolated first. So that 3 is being multiplied. To undo multiplication, we divide. 3 divided by 3 is 1. We get the quantity x plus 4 squared is equal to 25. Now we can square root both sides. We get x plus 4 is equal to positive or negative 5. Subtract 4 from both sides. X equals 4 plus or minus 5. Now this one we can actually simplify. So we can have x equals 4 plus 5, x equals 4 minus 5. So this is 9 and this is negative 1. So x is going to equal negative 1 and 9. So remember, a quadratic is going to have two solutions most of the time. This one here is two solutions as well, because there's a 2 plus and a 2 minus. All right, moving on to 24, isolating. Okay, number 24, we will need to isolate this squared. So we're going to have to get rid of this negative 3 and also get rid of this 1/2. Reverse PEMDAS tells us that we need to get rid of that negative 3 first. So undo the minus by adding. So we get 1/2 times the quantity 2x plus 5 squared is equal to 8. So divide by 1/2, divide by 1/2. Dividing by 1/2 is the same thing as multiplying by 2. Well, I'll write it like this. So divide by 1/2, divide by 1/2. These divide to be 1. We get 2x plus 5 quantity squared is equal to, remember dividing by 1/2 is really multiplying by 2. So that becomes 16. Square root both sides. We get 2x plus 5 is equal to positive or negative 4. Running out of some room, I'm going to make this go all the way up here. So we get 2x plus 5 is equal to plus positive or negative 4. Subtract 5 from both sides. We get 2x is equal to negative 5 plus or minus 4, and then divide by 2. X equals negative 5 plus or minus 4 divided by 2. And we need to simplify because those are all integers. So we get x equals, for the sake of space, let's see, negative 5 plus 4 is 1. It's a negative 1 divided by 2. Negative 5 minus 4 is negative 9 divided by 2. And we're supposed to write our answer from least to greatest, so that negative 9 would come first, and then the negative 1. There we go. Okay. And again, we can check our answer here. Let's see what it looks like. Ooh, Desmos. Type in the original. So this time we're solving. Solving, we can do the line 1, line 2. So 3 parentheses x plus 4 squared. And then we are comparing it to this right here, which is y equals 75. Large number, but let's hope we find some intersection points. So they intersect at negative 9 and positive 1. Interesting. Looks like I may have done something wrong. So let's see here. Minus 4. There it is. Minus 4. So a negative 4 right here. Negative 4 plus or minus 5. This was the mistake I made right here. And this is why we check our answers. It's almost like I did this on purpose, huh? Okay, so negative 4 plus 5 is a positive 1. And then negative 4 minus 5 is a negative 9. Least to greatest, negative 9 and positive 1. There we go. All right, number 25. Find the solutions to the equation of the form f of x is equal to 0. If each table and graph shows quadratic functions using f of x. Remember, solutions are the same as zeros. Solutions are the same as roots. Solutions are the same as x-intercepts, and any other way. All right, so find the solutions to the equation f of x is equal to 0. So recognize where f of x is. F of x is our y, right? This is our y. And here's a graph. So y, f of x is equal to 0 is the same thing as y is equal to 0. So we are comparing it to this line right here. And same thing with this one, y equals 0. Okay. Where does f of x equal 0? We've got this guy and this guy. We've got nothing here. All right, so negative 2 and 3. So when x is equal to negative 2 and 3, f of x is equal to 0. Here, let's see here. Notice that we have some inequality symbols. That's because it crosses that line right here in between some x values. So let's see. Given this table, we have 7, negative 10, negative 15, negative 8, and 11. So 0 would happen like somewhere in between here, right? And 0 would also happen somewhere in between here. So those are in between the x values of negative 2 and 1 and 1 and 2. All right, here, comparing the quadratic, the parabola, to the equation y equals 0. All right, so that's a negative 3 and a positive 1. And for this one, right here and right here, not perfect numbers, but we do know that the first one is in between negative 1 and 0, and the second one is in between 1 and 2. All right, real quick, I'm just going to, let's say, okay, let's say I wanted to compare this to this line. So what if I change the verbiage and I said, find the solutions to the equation of the form f of x is equal to negative 3. So negative 3 would be where the parabola reaches, touches, intersects the red line. So your solutions for that one would be those x values of negative 2 and 0. Okay. Moving on to inequalities. Solve each quadratic inequality. Your solutions might contain more than one x value. All right. Let's move this guy over here. We get x squared minus 11x is greater, minus 12 is greater than or equal to 0. Factor x times x is x squared. We have 1 and 12 will give us negative 11. So we have our x-intercepts are going to be at 1 and also at 12. And it's pointing up. So we can see the solution here graphically. We can also try some numbers as well. So like trying a number over here would be left of 1 would be 0. Trying a number in between would be a 1 and 12. Let's do 2. and a number outside would be 13. And all we have to do is compare it to whether or not it's greater than or equal to 0. That's real easy. Is it going to be positive or negative? So right here, if x is 0, I'm going to use this one. We have a 0 minus 1, that's a negative, times another negative is going to give us a positive. So again, we're trying to find out when is it greater than or equal to 0. Yep. 2 minus 1 is positive, times a 2 minus 12 is a negative. That's going to give us a negative. So this one is not in our solution area. All right, 13 minus 1 is 12. That's a positive. 13 minus 12 is 1. That's another positive. So positive times a positive is positive. That is greater than or equal to 0. So our solution is going to be from 1 this direction and 12 this direction, which you can also see graphically. Arrow. And then write your solutions in this form. So left to right. So all of these values stopping at 1, bracket, because this is a greater than or equal to, and then a union. Starts again at 12, bracket, and then continues going to the right, infinity. That would be our solution. Okay. Number 30, move that negative 3 over. I'm going to have to write a little bit smaller this time. We get 3x squared plus 6x plus 3 is greater than 0. We can take out a factor of 3 from each one. And we get 3x squared plus 2x plus 1 is greater than 0. Factor again, that's x plus 1 times x plus 1, greater than 0. So our only x-intercept is 0. When that happens, your graph looks like this. Your vertex is right here, and this is positive, so it's pointing up. And again, we're looking for when it's greater than or equal to 0. So that's going to be right here, right here. And this here is not a closed circle. It's going to be an open circle because it's just a greater than. Okay. So there's a tiny little break right there at 0. So let's see. Let's try when x is to the left. So let's try negative 1 right here. Negative 1 plus 1 is 0. 0 times anything is going to say 0. Is 0 greater than 0? No. Let's try a number above 0, like 1. All right, 1 plus 1 is 2. 3 times 2 is 6. And then this is x plus 1 again. Sorry, that's just going to be a positive times a positive, which is still a positive. Greater than 0? Yes. All right, number 30. Here's my pencil. All right, let's start by moving this negative 3 over. We get 3x squared plus 6x plus 3 is greater than 0. Excuse me. Divide everything by 3. We've got that common factor. It becomes 3x squared plus 2x plus 1. This is a perfect square trinomial. But in case you don't see that, you can still split it up like this. X times x is x squared. 1 times 1 is 1. And then adding to be 2 would be both positive. So this is really x plus 1 quantity squared is greater than 0. All right. So let's draw a picture of our graph. We have an x-intercept at -1. And it's going to be an open circle. And it's pointing up. And let's see here. It looks like greater than 0 is above, right? So it looks like almost the whole thing is a solution, except that one point right here at -1 is where that break is. So we would write that as -infinity to -1, parentheses, greater than, not a greater than or equal to, union, start again at -1 to infinity. So again, all of these here are solutions. Here, all of these were solutions. So this is how you write this amount of solutions. There's a ton of solutions, and this is how we write all of the possibilities here as well. Okay, let's move on to number 31. Move this over. We get 2x squared minus 7x minus 4 is less than or equal to 0. Reverse FOIL. We've got 2x and x, and then 4 is just 1 and 4, and that's the order it will go. So negative, positive. That means x cannot equal when you solve this, you're going to get 1/2. And, oh, it can equal, sorry, it's because it's a greater than or equal to sign. These are x equals 1, x equals 2. Those are our x-intercepts. We're going to write that here. Our x-intercept is at 1. Our x-intercept is at 12. Okay. Here, when you solve for x, let's call this a root this time. Our root is a positive 1/2. Our second root is at a -4. Let's draw a picture. So positive 1/2, -4 pointing up. And this time we are trying to find out when it is less than or equal to 0. So below that x-axis is going to be from here to here. This is a -4 and this is a 1/2. Okay, so to write those x values that are the solution, this is a closed circle because it's a less than or equal to. So that's going to be a bracket starting at -4, all of those values, and then stops at 1/2 bracket. Phew, okay. Let's just double check using our Desmos real quick. And we got this guy. Let's do this one. X squared minus 11x minus 12. And then y is equal to 0. Let's hit home. All right, -1 and 12. -1 and 12. And this is why we check our answers. All right, so this is a positive 1, which makes sense because it needed to be a -11, which means our x-intercept is at a -1 and a positive 12. So this is at right here at -1, going that direction, and positive 12. Again, that's why we check our answers. I'm curious, what would happen if I change this to the actual one it gave us. So like if I did x squared minus 11x and then y equals 12. Let's see if we get the same solution. -1 and 12. So again, all we can check right now is where that breaking point is of when it goes above or below the line that you are comparing it to. So for instance, the one I just graphed right now, you're comparing it to y equals 12, and which is the reason why you still get the same answer, because above this is going to be to the left of -1, which is what we got here, and above this is to the right of 12, which is what we got here. But when we make it equal to 0, we are able to solve by factoring using our brains and not the calculator. So that is why we like to make it equal to 0. Okay, let's just make sure we did this one right. Two x squared minus 7x. I'll do this one. Minus 4. And then y is equal to 0. -0.5 and +4. Did I do something wrong? Let's see. All right, -7. So if you look, 4 times 2 is a +8x, and then this is a -1x, but we wanted a -7. So -8x plus 1x. So what that changes is that this here was supposed to be a +1, and this here was supposed to be a -4, which changes this root to a -1/2, and which changes this root to a +4, which changes this and this to a -1/2 and a +4, which changes this and this to a -1/2 and a +4. Isn't it crazy how the smallest little mistake you can do changes your entire answer? So let me highlight where we made the mistakes the first time. So use yellow. This is where we made the first mistake, again with our signage. And then here, again, with the signage. So make sure we check, especially if time allows on a test. All right, number 32, give an example of a perfect square trinomial in polynomial and factored form. Let's see. Let's do simple, right? Perfect square trinomial. How about x plus 4 squared? So that's factored form. And if you were to multiply this out, you would get first times first, outside, inner, last times last. And then this is our polynomial form. And again, if you have that formula memorized, a squared plus 2ab plus b squared, you could have went straight from here. This is x squared, 4 squared is 16, x times 4 is 4x, double that is 8x. You get the same thing. Give an example of a difference of two squares in polynomial and factored form. All right, factored form would be like x plus 2, x minus 2. That's factored form. And when you multiply it out, it should only be 2 terms. Right, x plus 2 times x minus 2. First times first, outers, inners, last. Negative 2x plus 2x is 0, so we get x squared minus 4. And this is the polynomial form.